Okay, in this next unit, your next homework is going to be problems covering material that's covered in exercise set 3B, chapter 3, exercise set B. We are defining two concepts using truth tables and using the other concepts of sentential logic. Logically implies, logically equivalent. Okay? Logically implies, logically equivalent. In exercise set 3B, you're going to always be given two propositions labeled A and B, P and Q, P or Q. You're going to ask, does the first imply the second imply the first, and are they logically equivalent? Okay. A statement logically implies another. Okay. When every time it's true, the second is true, right? Look, every time P and Q is true, P and Q are both true, this is also true. So this implies this, logically implies this. Which means if I tell you P and Q are both true, you can deduce P or Q with certainty. Since this is true, this is true. Okay. That's logically implies. That's the concept of logically implies. Logically equivalent is always have the same truth value, no matter what. Okay. So, we're going to look at logically implies. Look at this example of logically implies. Talk about the concepts a little more, see how it works. Look at our procedure and go from there. Okay, so look what happens when we compare P and Q or P with P or Q. All right, here's the truth value for P and Q. Here's the truth value for P or Q. Okay, does this, which we'll call A, logically imply B? What we're going to do is look at the arrow statement between A and B, right, which is our materially implies. Okay. Does A logically imply B? Well, let's look at how this shakes out. I plug in these truth values for A and plug in the truth values for B. Okay. In row 1, A is true, B is true. Row 2, A is false, but B is true. False, but B is true. A is false, B is false in row 4. Okay, I've plugged in those truth values from up here. True, false, false, false comes down here. True, 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 false comes down here. Okay, true arrow true is true. False arrow true is true. False arrow true is true. False arrow false is true. This is why it was so important for us to define the arrow the way we did. Now we can use it to define logical implication. Look, this is a tautology. Okay. So when the arrow statement between the two statements is a tautology, right? What this is if I drew an arrow between these two, right, we'd get true, 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 right? You'll see why for reference you just want to label this A and plug in the truth values. Okay? This implies this is a tautology. So P and Q logically implies this. No matter what, P and Q, if P and Q is true, then P or Q is true. Anytime P and Q is true, P or Q is true. Okay? Some arrow statements are contingencies. Sometimes they hold, sometimes they don't. But this is logical implication. P and Q, anytime it's true, P or Q is true. The reverse does not hold, which is why I gave you this. Okay, so how about, does B imply A? Does B imply A? Does P or Q imply P and Q? Intuitively, you should see no, it doesn't. If I tell you at least one of these is true, you cannot deduce just from that they're both true. They could both be true, but it doesn't follow. It's not, this is not entailed by this. Okay? And we can use our test to show that. Okay, you see how I plugged in my truth values. True, 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 false comes over here under B. True, false, false, false comes under here over under A. This is why from previous work, knowing your main connectors is so important. You're going to take that and plug it in here. Now, there are times when B is true, but A is false for a given truth, right? For an assignment of truth values of P and Q. In scenario 2 and scenario 3, B is true, but A is false. Okay? The statement P or Q is true because one of them is true, but the statement P and Q is false because they're not both true. Not both, right? Remember that from chapter 4. Okay, so this statement is not a tautology. This statement is not a tautology. Since this arrow is not a tautology, answer no here. Yes and no. These statements are not equivalent. They don't say the same thing, and you can tell by the fact that you got a no answer to one of these. Okay? So if you get yes and yes, that means each implies the other, and they're equivalent. If you get no in either or both of these, then they don't imply. So are they equivalent? No. Okay? Equivalence says the double arrow between them is a tautology, and in this case it's not. Sometimes they have the same truth value, but sometimes they don't. Sometimes they have the same truth value, but sometimes they don't. You actually, but you can tell your answer from the first two. If A implies B and B also implies A, then they're also equivalent. You'll see that they always have the same truth value, right? But to test it separately, right, we had A double arrow B. A goes true, false, false, false. B goes true, 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 false. Right? Are they always equivalent? No. Sometimes they have the same truth value, sometimes they don't. Overlapping truth value is not the same as logically equivalent. Logically equivalent means they have the same truth value no matter what. Let's look at a logically equivalent one to see how this works. And I'll talk about where we're going with this. Now P and Q. Okay. Let's look at not P or Q with P arrow Q. Not P or Q, P arrow Q. Main connector, main connector. Right, so we get not P goes false. No, oh, sorry, I put the main connector incorrectly. This is the main connector. Sorry. And so we go false, false, true, true. Right, and so for this we get true, false, true, true. That's when either P is false or Q is true. Either P is false, Q is true. 3 scenarios, right? Q is true. Neither one goes here, but P is false here. True, false, true, true, and you know that's our chart for P arrow Q. Right? I'm going to call this A. I'm going to call this B. Does A imply B? We get true, false, true, true. True, false, true, true. Let me write that so it's a little more visible. Does A imply B? True, false, true, true for A. True, false, true, true for B. True arrow true, false arrow false, true arrow true, true arrow true. Okay, and the same for B arrow A. Since they have the same truth value in each circumstance, it's true, false, true, 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 false, true, true. Okay, you can see since these are identical, they're also equivalent, but that means you're also going to get yes answers here. Okay. Each implies the other, and so yes, they're logically equivalent. Okay, and if if you did A double arrow B, again, you'd have true, false, true, 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 false, true, true. They always have the same truth value. Right? This needs to be a tautology because logically equivalent means they have the same truth value no matter what, in any circumstance. They have identical truth conditions. In any scenario, they're going to be true. Each one will have the same. In any scenario, they'll have the same truth value, either both true or both false. Okay, we've looked at these as being equivalent, right? Not unless. You can't have P unless Q means P implies Q. Okay, so logical equivalence means each implies the other, which means they always have the same truth value. Always meaning in every possible scenario, regardless of the truth value of the parts, right? They have identical truth tables, if you will, or at least under the main connector. Okay? All right, so that's your procedure. So, logically implies means, right? A logically implies B means whenever A is true, B is also true. You test that. You can use the arrow to test that. Is the arrow statement between A and B a tautology? That is to say, right, is it true that every time A is true, B is also true? Right? When A is false, doesn't matter, and then you get a true when A is right, when the antecedent is false in the arrow. So the concept of logically implies is anytime A is true, A logically implies B. Anytime A is true, B is true. Okay? One proposition entails a second, so long as every time the first is true, the second is also true. Doesn't matter if sometimes the first is false and the second is true. That doesn't matter. What matters is that every time the first is true, the second is true. That means that is what we mean by the first implies the second. And they're logically equivalent when each implies the other, which means in every circumstance they'll have the same truth value. They'll have identical truth values because identical truth conditions. That's logical implies, logical implication. This is our truth table test for it, a procedure. Got the procedure explained in a handout. I will also practice some of the exercises to further reinforce this. Okay, so I'll have the next video on that.